Good morning. I'm Colonel Ed Brown, the Army Program Manager for the Advanced Attack Helicopter Weapon System. We're here today at the Hughes Helicopter Test Laboratory, and we're going to talk to you about the combat survivability features of our Advanced Attack Helicopter. On modern battlefields, our aircraft attack systems will have to contend with an integrated array of threat weapons that is indeed awesome. Now, we know that our potential adversary will, in fact, employ an integrated array of automatic cannons, radar-directed missiles, and IR heat-seeking missiles that span the spectra of sophisticated air defense weaponry. By the Russians' own definition, a curtain of steel. Against numerically superior forces so equipped, our aircraft attack systems must be designed to where they'll be able to live, fight, and survive to fight again in order to win. Now, in my judgment, survival depends upon three basic ingredients. First of all, we must design in, beginning at the drawing board, toughness in the basic airframe. Secondly, we must ensure that the lethality of the weapons that we integrate into the system are optimized. And last, the tactics which we must employ the system under have got to be designed for the future battlefield. Now we're going to show you what the Army and Hughes helicopters have done and is continuing to do to improve the design, the weaponry, and the tactics to make absolutely certain that our advanced attack helicopter will survive while exacting heavy losses in enemy armor on future battlefields.
Three world forces are facing a formidable, numerically superior array of enemy armor, ground forces, air and air defense weapons deployed in depth along the forward edge of the battle area. Threat air defense systems use infrared, radar, and optics for acquisition and can deliver a massive volume of accurate firepower. The introduction of the Russian attack helicopter into packed forces greatly increases their surprise and blitzkrieg capability. To successfully defeat this enemy, our forces must be highly mobile and must be able to acquire and kill targets at long ranges, around the clock, and during periods of inclement weather. The Army's YAH-64 Advanced Attack Helicopter is a weapon system that can do that job. Its flight performance, long-range integrated weapons, and day-night adverse weather capability are specifically designed to defeat this modern enemy. The tactics and techniques employed on the battlefield by the two-man crew take full advantage of new technology built into this helicopter. The primary tank-killing weapon is the Hellfire laser-guided missile, launched from pop-up firing positions outside the effective range of hostile air defense guns. The 2.75-inch folding fin aerial rockets and 30-millimeter cannon are employed against personnel, materiel, and lightly armored vehicles. Nap-of-the-earth flight minimizes the probability of detection and engagement by hostile forces. The target acquisition designation system and pilot's night vision system provide the crew fire control for the onboard weapons at maximum range and the capability to complete day, night, and inclement weather flight operations. Using unimproved landing areas well forward, the crew receives their latest intelligence directly from the supported tactical unit commander. Refueling and rearming in the forward area reduces reaction time and increases the available time on station. The agility, maneuverability, speed, and weapons provide the AAH its basic fighting capability. Proven, hardened design features and a suit of aircraft survivability equipment enhance the survivability and effectiveness of this fighting machine. It can repeatedly engage the enemy, survive, and be ready to fight again. The small size and four-blade main rotor system reduce the silhouette and minimize rotor flicker. The scissor's tail rotor reduces noise levels. The hot metal plus plume infrared engine suppression system and darker colored low IR reflectance paint, in conjunction with the flat plate canopy, defeat the current IR missile threat. These signature reduction features make visual detection difficult, and jamming of postulated improved IR threat systems a relatively simple task. When the AAH must operate within the range of threat radar-directed guns and guided missiles, the ANAPR-39 radar warning receiver provides the crew vital information. This system gives timely and accurate relative location and imminent capability of the threat to bring fire on the helicopter. When a threat radar system is scanning the battlefield in search of a target, the AAH crew will receive a visual display on the cathode ray tube and an oral tone. The crew can monitor this signal and continue the mission, aware that a threat radar is searching. If the radar detects the AAH, it will stop scan and lock on in preparation to fire. The crew will then see this display, hear this tone, and know that if within range, rounds will soon be on the way. The relative bearing indicated by the direction of the strobe and length of the strobe tells the pilot the approximate location of the threat radar. He can now make a decision whether he should continue the engagement or remask to break lock and resume the attack from a new location. If the helicopter does remask, the radar will break lock and the pilot may receive a scan indication as the threat returns to search mode. The threat system is unable to bring radar-directed fire on the helicopter. If terrain limitations or urgency of the mission will not permit masking to break lock, the AAH can stand and fight when equipped with the AN/ALQ-136 lightweight radar jammer. As the helicopter approaches the radar weapon, the radar warning receiver displays a steady strobe. Here is what the threat radar would see with the jammer in operation. Each time the radar attempts lock-on, the jammer throws it off and the radar returns to search. The threat system is unable to get a fire solution and thus cannot bring the helicopter under fire. The AAH with jammer has defeated the radar mode. An alternative to defeat radar threats is the XM-130 chaff dispenser system. This countermeasure consists of a dispenser, an electronics package, and a cockpit control unit. It can electrically fire a pre-programmed number of chaff cartridges that contain several chaff cuts to defeat a variety of threat radar systems. Under normal maneuvers, the threat weapon is able to track the helicopter. To employ chaff, the crew would monitor the radar warning receiver. When lock-on is indicated by a steady strobe and oral tone, the crew would fire chaff, the radar would lock on the cloud, and the AAH would move out of the radar resolution cell of the threat radar. Signature reduction features defeat current IR threat missiles and makes jamming of improved threat systems relatively simple. The AN/ALQ-144 IR jammer will confuse advanced missile seekers by generating false guidance commands that steer the missile away from the helicopter. This lightweight jammer has been proven effective when installed and operated on existing aircraft. An alternative IR countermeasure is the XM-130 dispenser system using flares. During actual range tests, a missile detector and XM-130 flare dispenser were mounted on a cable car. An onboard infrared source was used to simulate the aircraft energy. A surface-to-air missile gunner acquired and fired at the cable car. The missile homed in on the IR source, but the detector sensed the approaching missile and the deployed flare decoyed the SAM from the cable car. If the AAH is hit, it is designed to survive. Its ballistic tolerance is gained through use of failure-resistant materials, innovative design, and armor. The main transmission has demonstrated the capability to operate for a minimum of 1 hour after complete loss of oil. Widely spaced twin engines, backup fly-by-wire control system, dual hydraulic and electrical systems contribute further to the ballistic tolerance of the AAH. Rod end bearings survive 12.7 millimeter hits without jamming or failing. Grease-lubricated tail rotor drive gearbox and drive shaft can also survive 12.7 millimeter hits. Tests have shown the capability of the main rotor blade to withstand a worst-case 23 millimeter hit and continue operation for more than 5 hours. Self-sealing fuel cells will not burn or explode following impacts by a 23 millimeter round. Crew compartments are armored and separated by a clear fragmentation barrier which precludes loss of both crew members from one 23 millimeter HEI hit. Crash-worthy features of the AAH assure the crew a high probability of survival. The progressively yielding landing gear, yielding 30 millimeter gun mount, and nose plowing capability limits cockpit deformation during impact. Non-flammable hydraulic fluid and crash-worthy fuel cells limit the potential for post-crash fire. Wide canopy doors permit rapid egress. The Army's AAH will join the first line of defense. Flight performance, ballistically tolerant components, weaponry that enables it to be an effective tank killer, and tactics that deny the threat the opportunity to engage it will allow the advanced attack helicopter, like no other aircraft system planned or existing, to accomplish the attack mission in day and for the first time at night and in bad weather. And it will survive to fight again and again.
As you have just seen, the Army and Hughes Helicopter Company have done a lot of work to make the advanced attack helicopter the most survivable helicopter the world has ever seen. The Army is dedicated to being able to fight outnumbered and win. Now, to achieve that objective, in my judgment, two indispensable elements exist. First, we must have tough, intelligent, dedicated fighting men, and second, superior aircraft weapon systems that give us the opportunity to go into battle and to come away victorious. Ladies and gentlemen, your soldiers of the Air Cav and the attack helicopter pilots and the advanced attack helicopter system make up that kind of a fighting army.